Hi, in this video I want to explain how you can find yield to maturity of a bond in two different cases. In the first case, you have an integer number of periods till the maturity of the bond. And in the second case, you have a non-integer number of periods till the maturity of the bond. So let's start from the case that is easier. Assume that in the first case we have 5 years till the maturity of a bond. The face value of a bond is $1,000. In other words, you will receive $1,000 at the end of the life of the bond. And you know that coupon payments happen semi-annually. So you have 2 coupon payments per year. And you know that term to maturity is 5 years. So number of periods that you have in 5 years will be 10 periods because you will have 10 6-month periods. Then you know that you will have 10 coupon payments because you will receive coupon payments semi-annually. Coupon rate is given to you as an annual percentage rate and it is 4.87%. But you know that in fact your coupon payment happens every 6 months. So you should find your periodic coupon rate. How do you find that? You divide your annual coupon rate by the number of periods that you have in a year. You have 2 6-month period in a year, so divided by 2. So 2.43% is the coupon rate for a 6-month period. So you want to see in this question you are asked to find the yield to maturity of this bond if the price of a bond at time 0 is equal to $1,020. In order to do that, in order to find yield to maturity, first you should find all the cash flows of this bond. So we know that a bond will have coupon payments, in this case every 6 months. And you know that at the end of the life of a bond, you will receive par value. Here it is $1,000. How do you find coupon payments? So you found coupon rate for each period, for each 6 months. So in order to find coupon payment for in a 6-month period, what do? You multiply your 6-month coupon rate by face value. So each 6-month period, you will receive $24.38 in coupon payments. How many periods will you receive that? For 5 years, and each year has 2 periods. So for 10 periods, you will receive that. At the end of the life of a bond, you will receive $1,000. So your net cash flow for each year. So from in year one, you receive only your coupon payment. In year 2, your coupon payment. But in last year, you will receive $1,000 plus your coupon payment. So you have all of the cash flows of your bond. You have the current price of your bond, $1,020, and you want to find yield to maturity. So first, let me explain what is yield to maturity. So we know that yield to maturity is the discount rate that makes the present value of all the cash flows of a bond equal to its current price. So if we set price equal to first cash flow divided by 1 plus a discount rate to the power of number of periods that we have. So this cash flow is in period 1, so to the power of 1. And you find the discount rate for the second cash flow in the same way until the cash flow at time t, which is the maturity of the bond. So this discount rate that sets the present value, the sum of the present values of all cash flows equal to price, this is periodic yield to maturity. So if you multiply R by the number of periods that you have in a year, it gives you annual yield to maturity. This is an annual percentage rate. So So it is important to understand that yield to maturity is the periodic rate of return or annual rate of return on a bond if you go and buy the bond at the current price, okay? And you reinvest all the coupon payments that you receive from that bond at the same rate, at the same yield to maturity. So it is important to notice that yield to maturity is in fact the internal rate of return of investment in a bond. Why is that? Just take price to the right hand side of this equation. You will have 0 equal to minus price, because price is a cash outflow. It's your initial investment in the bond plus the present value of first cash flow plus present value of second cash flow till the end, present value of the last cash flow. So in fact, you are seeing that your discount rate is setting some of the NPV of this bond, or some of the negative cash flows, some of the present value of negative cash flows and present value of all positive cash flows. It is putting this sum equal to 0. That's the definition of internal rate of return. Internal rate of return is a discount rate that sets NPV of a project or an investment equal to 0. So yield to maturity is in fact the internal rate of return of investment in a bond. Now I want to use this fact and find yield to maturity for this bond. Okay, how do I do that? So because I want to use goal-seek function in order to find internal rate of return, first I define the net present value of this project. So net present value, we use the net present value function. The rate that I want to use to discount the cash flows of this project, in the end this rate will be exactly R that you have in your formula. So I just choose an empty cell for it because I don't know what R is, right? And then I put a comma. Then I should choose the values. For NPV, you choose the values from first period till the end. Then if you have any cash flows at time 0, you should add it separately. Here your cash flow at time 0 is your price, but because you pay the price, it is a negative cash flow, so you should subtract your price. So this is the net present value of investing in this bond. And you want to see which discount rate makes this NPV equal to 0, right? So then click enter. So in this cell, what I'm finding is my IRR, okay? How do I do that? Go to data analysis, data section in Excel, what if analysis, choose goal seek, choose the cell that you want to, your objective function. Here my objective function is that I want to set net present value of this investment, of this bond, of investing in this bond equal to 0 by changing my discount rate, because I want to find internal rate of return. And then I click OK. So you see that it gives you the rate of 2.21%. As I told you, this is your R. This is internal rate of return of investing in this bond at $1,020. If you want to find yield to maturity, usually yield to maturity, most of the cases it is reported as an annual percentage rate. And we see that we have coupon payments in every 6 months. So your payment period is 6 months. You want to make this rate an annual rate. So you should just multiply this 6-month period, because your discount rate is a 6-month period. You should multiply it by 2. So you can find your yield to maturity. So your yield to maturity is 4.42%. So this is how you find yield to maturity for a bond. Now let's go to the second case. In the second case, which is more complicated, you have 4.66 years remaining. How do you find that? So they gave you 2 dates. One of them is a maturity date of a bond, which is the time that the life of a bond will end. The other one is the valuation date, the date at which you want to find the price of a bond or you want to find the yield to maturity of a bond. So you have these two dates, right? In order to find how many years remain till the maturity, just find the difference between these two dates and divide it by the number of days that you have in a year. Here we are assuming we have 665.25 days per year and click enter. So this should give you a number. So let me make it a number. Okay, so this is a number, 4.66 years. Okay, so you know that 4.66 years is left till maturity. So how much time is passed from the first day of issuance? Okay, from time 0, the first day of issuance. In order to find that, you know that the real maturity, the maturity of this bond is 5 years. So from that 5 years, subtract 4.66 years. So it shows to you that you have 0.337 years passed from the date that the bond was issued. So you want to find yield to maturity at this point in time. So at point of 0.3374 years. Okay? So first, notice that this is 0.3 years. You know that each cash flow or each payment on this bond happens every 6 months. So how many periods do we have? You should multiply this 0.33 by 2 because each year has 2 6-month period in it, right? So you want to find the yield to maturity at this point in time at 0.33, right? How can we do that? And how do we want to do that? We are told that the price now is $1,020 at this point in time at 0.6748 periods. Okay, so at this point in time the price is $1,020 and you have the cash flows of your bond. You want to see what is the yield to maturity of the bond. Okay, the problem is that it is not easy to find the present value of cash flows of this bond at this time period of 0.67. So what do? First, we find the net present value of all the cash flows of this bond at time 0, right? At time 0. Okay, let's do that. Why is it at time 0? Because when you use it, when you find the present value of these cash flows, it gives you present value 1 period before your first cash flow. Your first cash flow is at period 1, so it gives you the present value at time 0. Okay? So how do we find that? Use the NPV function using your discount rate. Okay? For example, assume that I use an empty cell. Okay, because I don't know what is my discount rate. Okay, I want to find the discount rate that makes the NPV equal to price, and then I choose the values that I have. Here we have all the cash flows in our bond, right? Because the period of time that I want to really find the yield to maturity is before all of the coupon payments. So I consider all of the coupon payments in the value of a bond. So this is the net present value of all the cash flows of this bond. This is at time 0. But do I want net present value at time 0 to be equal to 1,020? No, you want NPV at t equal to 0.6748 48 to be equal to 1020. So you should use the future value formula and move this present value at time 0 to value at this time t equal to 0.67. So let's do that. Use the future value formula. Again, the discount rate that you use to move the cash flows to future is again your interest rate, discount rate that you don't know. How much do you want to move it in the future? You want to move it from time period 0 to period 0.67 period. So just choose this cell. Okay? So this is what you have at time 1, at time 0.67, 6-month periods, right? So this is the present value of only your positive cash flows, right? But we want to subtract our negative cash flow, which is price of the bond at this point in time, at 0.67 6-month period. So subtract your price, okay? So if I find a discount rate that sets this equation equal to 0, it means that I found a discount rate that sets the present value of all the cash flows of the bond at time 0.67 equal to the price at time 0.67. So in fact, that's yield to maturity. So then click enter. Now we want to find this discount rate. So you go to data tab, you go to what if analysis, you choose goal-seek function, and then you set the cell that is your MPV. You want to set your cell equal to 0. You want to find a discount rate that makes your MPV equal to 0 by changing which cell? The cell that is your discount rate. And then you should click OK. So you see that you found 2.39% for your discount rate. This is your internal rate of return of investing in this bond at the time of 0.67 6-month period of a 6-month period, right? But I told you that yield to maturity is you should report it on an annual as an annual percentage rate. So how many periods do you have? So this 2.39% is a discount rate for a 6-month period because all of your cash flows happen in 6-month periods, right? So, but you want to make it an annual rate, just multiply this rate by 2 and click enter. So your yield to maturity is 4.79%. So you learned how to find yield to maturity in 2 different cases. In the first case, the number of periods remain till maturity is an integer, and in the second case, the number of periods remain till the maturity of a bond is not an integer. Okay, thank you very much and bye.